Go to your Moodle account, sign in there, and select the course SolidEdge training. So lesson 1, 2, 3 and 4 you can see. So we have completed till lesson number 4. So a few changes I have made to this course. Initially, to access the files you had to go inside the page, and below the video you had to open the link. Fine. So to make it easy for you to access those links, I have kept those links at the top itself. So below this video link, you can see there is a link to access presentation. You can just click on this. It will open up in a new window like this. And to access the practice files, you can again click on this lower link, and the Google Drive containing all the practice files will load up here. Okay, so you can continue to download suitable version of the file from here and start practicing. So let me just close all this. So today we are moving forward with lesson number 5. And there it is, the presentation for lesson number 5. So here is the presentation for lesson number 5. Let me just quickly go through all the slides. So you can just watch this video as well. If you were unable to attend the live session, you can just watch the video, and this person is going to explain each and every step, what you have to do, how you have to do and all. So the only difference is that he will be accessing all these lessons from a single folder which is saved on his computer. I have uploaded all these lesson files to Google Drive, and for each lesson I have given a separate link for you to download. You can download the practice files lesson wise and you can practice. Fine. So I'll be explaining each and every step, how you can do, or what you can do and all those things. So just follow the steps and you'll be good to go. So let's go through the slides one by one. So it all starts here. Fine. So this steering wheel is very, very important for doing modeling, to model any solid, anything in SolidEdge. Fine. So it plays a very, very crucial role. So whenever you select a face or anything, there is something called design intent, and there is something called design intent which starts working. Okay, it's very, very important for us to understand how this design intent works. So let me just start with some random object. Okay, so let me start with the new, go to part. Okay, fine. That usually happens a lot of times. All right, so the entire screen, there it is. Fine. So today online, or you're the only one who's attending. So okay, you can start with a new file, and then can you see the screen? Hello. Right. So yes, so you can start drawing anything you want from here. So as soon as you select any draw command, you will get the option to select to lock one of the planes. Okay, I think someone is trying to join. Anyone joined? No. Fine. So first you'll have to select the plane, whichever plane you want to draw on. Just keep your cursor on that and then press F3 to lock it. Once the plane is locked, okay, so first you have to lock the plane. So keep the cursor, press F3. Now it is locked. Now whatever you draw, it will be drawn on that plane alone. So let me go for 75, press tab, 40, enter 2 times for the rectangle. So the rectangle I have created. So now, as I had told in the previous session, so you can just click on any closed surface or face of any solid, and you will get this option. So there is a sphere which you can drag and place wherever we want. If we are placing the sphere on a flat surface, we will be able to do extrude. Fine. And if we drag the sphere to one of the edges, we will be able to rotate this. Okay. So if it's a solid, it will just give a draft angle to whatever face we select. And if we are starting out with a sketch like this, okay, I'll have to hide this. If we are starting out with sketch like this, then we can drag it to one of the edges, and then we can do revolve. Okay, so you can see this is getting revolved. So whatever angle you want, you can feed it. If you want complete angle, you can just feed 360 degrees. If you want complete angle, and press enter. So that will create the object of revolution. Fine. So you can extrude, you can do revolve it, or you can extend it based on some conditions, and all these things you can do it from right here. So okay, so the next thing we have to talk about is the design intent. Fine. So let's see if we have any ready-made files to work with here. So lesson 5, below lesson 5, practice files. You can just open it. So multi-align design intent block. So let's download this. Okay, so let's open that. Okay, so this is a design intent block. Fine. So you can see this block has been designed using some dimensions, but you can make changes without using dimensions as well. So you can just select whatever face you want to move. Wow. All right. Okay. Okay, let's go with dynamic. Definition. Okay, so what has happened here is that this particular feature, has been created as an ordered part. Fine. So this is non-synchronous or ordered kind of modeling technique. So the first thing we have to do is we should convert this into synchronous model if you want to use that. Fine. So the option for conversion you will get somewhere. Yeah, so transition to synchronous. So before converting any ordered kind of model into synchronous, we have to right click on this ordered and select transition to synchronous. So once you make that transition, after that, what happened here? Okay, so that is transition. Oh. So we want to convert this into, okay, so that thing. Let's just watch this video to completely understand this. There are some things which are new here in the SolidEdge for me as well. Hello.
27.5 to subtract.
Okay.
And this is all about design intent and relate faces. So first of all, we need to understand what design intent is. So, design intent is how you desire or expect a model to react when you do a design change. So I'm going to open that up, explaining design,
So let's
that there's
open
some
that.
design changes that need to happen. So this needs to be 100 millimeters wide. All the material needs to be added to the back side. In other words, I don't want this angle to change. I don't want this distance to change from face to face. Also, the lug here in the middle needs to be 45 millimeters. And now this was done in ordered modeling, right? History-based modeling. So let's take a look at that. I'm going to hide the PMI dimensions and I'm going to do a go-to so you can see how it was built. First of all, a profile was built and extruded. Then a cutout was added. And then a second cutout was added. And then the part was rounded. Okay, so if you think about how this is built, remember we said we want the centerpiece to be wider. Well, the only way to get that wider is to remove, 7.5 millimeters from each of these numbers, each of these cutouts to make that wider. So you got to kind of work backwards. Even making this simple edit to make this 100 millimeters wide can be a challenge in ordered modeling. So let's go look at that. I'm going to go to the profile of that sketch that was drawn. And I want to make this 100. And then it moved the wrong side. It pushed this out to the right. And it changed the angle. I don't want to do that. Why did that happen? Well, if this gets wider here, it also needs to get wider here. This is a locked dimension. That means it can't change. So I'm going to unlock that dimension so that it can change when I change this number. Still did the same thing. Why did it do that? Well, again, when this thing was built, this midpoint was lined up on the coordinate system with this alignment. Well, that's preventing this from growing to the left. So I need to take that relationship and delete it. Now, none of those things were wrong at the time the part was built because that was what made the part what it was. It's the changes now that become a problem because it prevents us from changing it the way that we want to. All right, so now I've extruded that, but what happened here? Well, my cutout doesn't go all the way through. Why did that happen? Well, whoever modeled this, when you get to the extent step for the cutout, instead of saying through all, they just picked a point that was through the part at the time, which was fine, except now the part got wider. It remembers where that point was clicked, and that's all the further it goes. So really, this should have, they should have used the through all, pointed in both directions, and that way it doesn't matter how wide it gets, it's always going to go through the part. All right, let's finish that. All right, then, we said we want this to be 45 millimeters wide. So I need to go to this cutout. Let's go to its profile. And so from the center point, I need to add then, on this one, I need to add half of the 15 millimeters that I need to add to make it 45. So I'll do plus 7.5. And then I need to subtract that 7.5 off of this dimension. It's 27.5. Okay. So that created that cutout. Now this one is shifted over and it's not on center. What happened here? Let's go to this cutout. Let's look at how it was dimensioned. Okay, and it was dimensioned from the other side. So that's going to be 45. And again, this is going to have to be 27.5 to subtract That's 7.5 millimeters. So it's a lot of calculations and things to get the final result that we want. Remember, this needs to be 20 millimeters taller. Well, that's a bit of a problem because I have rounds on here, and yet I need to extrude this up. So, oops, I would have to go in here and create an offset plane, maybe parallel plane, and we want to bring it down to there, and then we're just going to use the project to sketch. So we're going to sketch on that plane, and then we'll use project to sketch. Pick up these edges, then we'll trim them together. So that we get something that we can extrude. And now we need to go 20 millimeters plus whatever that radius was, and I didn't pay attention to what the radius was, so let's go back. That's a 5 millimeter radius, so I need to go 25 when I do my extrude. Selecting from the sketch, and we're going to come up 25. So I added my 20 millimeters from where it was, and then we need to add our radius back on. Okay, so that was a lot of work, right? So the design intent really, if I would have thought about that, or whoever, when they modeled this, would have thought about that, they would have modeled it a little bit differently so that those edits would have been made easier. However, with synchronous technology, let me close that. So let's reopen the file. And this time we're going to move all of those to synchronous. So those features are now synchronous features, which now the order doesn't matter anymore. I'm going to go into the PMI here because what happens is it basically doubles the dimensions because every dimension that was in the sketch gets transferred. So I'm going to take all of those dimensions and I'm just going to delete those so I don't have any extras. Alright, so I have my PMI dimensions on there now, and so now any change I want to make, I can make. It doesn't matter how the part was modeled. When I get to here, this dimension, I pick the side that I want to move, and I simply change it. I don't have to worry about, well, how did they build the model? I don't have to worry about that cutout not going all the way through. It's always going to go all the way through because that's how it was modeled. I want to change this dimension. I want to make it 45. Okay. If I didn't want these to change, I could have come in here and locked this dimension, meaning don't allow that to change. Yet when I change this, it keeps it symmetric, makes those the same, and makes it wider. If I want this to be taller, I would turn off my design intent for coplanar. Okay, I don't want anything to move coplanar, and I would pull this up 20 millimeters. Simple and easy. I don't have to worry about anything, right? I change whatever I want, wherever I want, however I want, no matter how it was modeled. So that's what I'm talking about with flexibility of design intent when using synchronous technology. Okay, let's go back to the PowerPoint. So the design intent panel that you saw me change that coplanar, turn that coplanar off, that's the proprietary tool in SolidEdge that makes synchronous work. So whenever a face or set of faces is moved, at that time SolidEdge goes out and looks for these geometric conditions within the part. If it finds that geometric condition, it maintains it as long as that checkbox is checked. So in other words, when these holes were moved to the right, it went out and checked and said, yep, I found symmetry. So the holes on the other side are going to move. It also found that the hole was concentric to the radius, so it maintained that concentricity as those moved out. Those radius or those radii had symmetric faces on the other side, so they moved. Okay, and coplanar faces. So from the top to the bottom, it found those coplanar faces, moved everything together. So um, that's how that works. So, design intent can also be done by selection. So in this case here, pick multiple faces and move them. You can have all the design intent turned off and all those faces are going to move together. Okay. Design intent also works with dimensions. When you click a dimension, that design intent panel is going to show up, because not only just dragging can use design intent panel, so does changing the dimensions manually. One dimension can be used to change multiple faces. So in this case, box selected a bunch of faces, pick the dimension, start modifying that dimension, and all those faces are going to move with that change in the dimension. Anytime you see a blue dimension, that's an unlocked dimension, meaning you can change that dimension directly, or it can be affected by the change of another dimension. If the dimension is locked, if you click the little lock button like I did on that previous example with the design intent, where I changed the cutout to a locked 35 millimeters, that means the only way that dimension can change is if I change it directly by clicking on it. Changing any other dimension will not modify a locked dimension. Okay, you can control the direction of the editing, so depending on which face you want to move, whether you want to move the left side, the right side of the dimension, or keep it centered. You have those options. So what are the different design intent relationships? This just shows you an example of, maintaining concentric. So you have a hole and an arc here, and they're concentric, coplanar faces. Symmetry is always symmetry about the base coordinate system. Okay, so it's always going to keep that symmetric. Aligned holes are aligned along the x and the y or the z axis of the coordinate system. And so here's the next example. This is the one I did for the demo. And so I'm just going to go open that up to show you what I do there. So we'll browse back to our same folder. I'm going to open up the support base. So with this support base, what we're going to do is introduce the different design intent relationships one at a time so you can see exactly what they do. So let's go to, I'm just going to select a hole, and then I'm just going to disable each one of these individually. And so if I were to move that hole using the plane, I'm moving it around and it's just moving independently because it's not finding any other geometric relationships within the part. I'm going to click escape one time. We'll keep the select set, and I'm going to turn on symmetry. Now if I do a move, you're going to see that the holes in all four corners move. The reason they're all moving is because that hole is symmetric about the coordinate system in two different directions. So about the YZ plane and about the XZ plane. So it's picking up the symmetry, it's maintaining that geometric condition. Now I'm going to turn on concentric. So the hole is concentric to the outside radius, and so as I begin to move, you're going to see it remains concentric. The faces remain tangent to the outside radius, and it's also symmetric. So everything, all four corners are moving. Next thing I'm going to introduce is aligned holes. So now it's going to move all the holes and keep them lined up with each other, moving symmetrically. And so as long as they're aligned along the X, Y, or Z axis, it will maintain that alignment. Now let's take a look at moving this top face. When I move this top face up, you're going to see the face on the opposite side move because of symmetry. You see the symmetry is found. You also can see that offset and coplanar are found, but they've been disabled. So when you start to do the move, it drops the list to only the things that it finds. And so I'm going to click Escape. There's the default relationships. I'm going to turn on Offset. And so you can see that there's a small offset face inside of there. It's inset. And so now if I pull that up, you're going to see that it's going to find that offset face. Also finds as their symmetric faces, and they all move together. Click Escape one time and I'll turn on coplanar. Because all of these are coplanar, now as I begin to move that up, they're all going to move at the same time. Now let me just disable coplanar for a second. I'm going to pull this one up above the other two because I want to show you something else. So now when I click a face and I'm going to put this on rotate, I'm going to turn on all of the design intent so it'll find everything that it can, and I'm going to initiate a rotation of that face. Notice what happened, that it found symmetry and it found the offset face, but it did not find coplanar. Okay, even though these two faces are coplanar, it removed the coplanar relationship, and the reason it does that is because those two can fight against each other. So if you can imagine, if I turn off symmetry and I initiate that move, now coplanar will be found and it maintains coplanar. So it can't maintain a coplanar and a symmetry at the same time. So they made a determination that symmetry is the stronger relationship. Typically when things are symmetric, that's the relationship you want to maintain. Once you turn that off, then we'll go out and begin to look for other types of relationships like coplanar. So let's pull this back down to where they're all coplanar again. Now, what if I only wanted 2 of these faces to move, or 3 of these faces to move, and 1 get left out? Okay, so when I select this face and I start to do the move, it's going to find symmetry and it's also going to find coplanar. So I need to turn off coplanar because I don't want it to find this one. Symmetry will find this one, but to add this one in, I would just have to add it to the select set. So really I could just select those two, turn off coplanar, and do the move. Why is this one moving? Well, because this one is moving up, it's also symmetric. So I need to turn off symmetry as well, and then just add everything that I want to move in the select set and move it together. So sometimes moving by selection is the only way to get the answer that you're looking for. Notice that I can also add dimensions. So if I were to add a dimension between these two holes, and I change that dimension, symmetry also still comes into play. Let me reset my design intent by just tapping R. It resets all of the default design intent relationships. So as I begin to change that dimension, it doesn't matter which way the arrow is pointing because they're symmetric. It's going to move them in both directions. Now notice that the design intent still kicks in. It still finds the aligned holes, still finds the concentric, still finds the symmetry. So whether you're clicking and dragging faces or using dimensions, design intent works exactly the same. So there are a lot of different face relates that you can create between the different faces in your part. So if you have things that are not lined up or not where you want them, you can use these face relates. It's kind of like in 2D when you have 2 lines you want to be collinear, or you have a line you want to be perpendicular with another line. You have those same things in 3D with faces. So these are all the different kinds of face relates that you can create. You also have the option to persist them, meaning they will be added to the model and it will forever be there unless you delete it. And it no longer relies on design intent to maintain it. So if I say these two are coplanar and I save that as a relationship, even if I turn off coplanar when I start to move that face, because they're locked to be coplanar together, it's going to be maintained. Concentric, maybe I have a hole that's off that I want to be centered on this radius. I would use the concentric relationship, and in this case it's persisted, so it gets added as a permanent relationship in the model. So how it works is the seed face, the face that you pick first, is going to move to the target. Okay. By default, the relationships are persisted. As a rule of thumb, I turn off persisted if I know that a design intent relationship can maintain it for me, because I don't really want to build the overhead within the model if I don't need to. You have an option for single align and multiple align. Let me just show you what that is. It's easier to show than to try and explain. So we have a model just for this called multiple align. So here I have this block and it's got 4 faces here, and they're all at different levels. So what I want to show you is multiple align or single align. So I'm going to select, remember the space bar makes it so I can add faces. And I'm going to use coplanar. And so the two options I have are single align or multiple align. I'm going to have it set to multiple align. Notice they're all bright green. That means that all the seed faces, all the ones I selected, are going to move to one target face. And they're all going to be at the same level. Okay, so that's multiple align. That's probably the one you're going to use the most often. Single align allows you to select these faces again. And I'm going to change this now, coplanar, and I'm going to change the option to single align. Notice that only one face turns bright green and the other two are dark green. So the bright green face is I need to tell it what face do I want to align it with. And I'm going to click this, and you're going to see these two are
Hello,
just
sir.
along for the ride.
Oh, yes, ma'am.
They're going to move up.
Sir, yesterday's problem I didn't get, sir, till now.
Yesterday you have a doubt in yesterday's problem?
Yes, sir, it is not saved.
Yes, yeah. Yesterday afternoon, or evening also you tried to contact me, no?
Yes, sir, yes, sir. I tried, but it did not get there.
Okay. So your system is connected to internet?
Yes, sir.
Yep.
Any days, can you check it?
248600, no?
Yes, sir.
Yeah.
Relative, but they're not all going to be at the same height. Okay.
So it's not showing
And I
online.
accept it. It's going to drop out that one. It's going to go to the next one. So okay, what do you want to line that face with? I want to line that with this one. This one's along for the ride. It just drops down with it. And then I accept it. And then that one drops out. And this is, which one do you want to line this with? I want to line that with this one. Okay.
Sir, no.
So that's the difference between single.
Still not showing.
And multiple align.
Yes.
Yep. Did you get it?
Yes, sir.
Yeah.
And then finally we have this example here where we're going to take this orange part and we're going to try and make it match the blue part here. So I can see that these are all at different levels. So these need to be all at the same level in the end. I can see that there's some angles in here.
Yes, ma'am.
Sir, how to save this? It is showing no top level part selected.
Achha, yeah, that problem now. You didn't save it yesterday?
Sir?
You didn't save it yesterday?
No, sir.
That means you didn't close the file since yesterday?
Sir, I closed, but it's already saved file, sir.
So today when you opened, it has opened as a edited file, no?
Yes,
so that
sir.
means
Yes.
it got saved.
Directly it will come.
Yeah, no. All the changes you made, they got saved, no? So maybe it's just an error. By mistake it is showing that. Because all the changes you made were saved. Once you close this file.
This file only, sir?
Yeah, this close it.
Yes, sir.
Did you close the file?
Sir, I close it. Here.
Okay, now open it again. See, all the changes you made, they have got saved now.
Sir,
So that is just maybe some error. Don't worry about that. Okay. Maybe it's just a warning, but
it's done. Sir, it's saved.
it's saved now because it's opening now. Whatever changes you made, they're opening correctly.
Ah, sir.
That means it's saved. No problem. Okay.
Okay, sir.
All right.
And I want to make these concentric, so I'll go to concentric. I want to make this hole, accept it. I've turned off persist. It's on by default. I've already turned it off, so it remembers. It's left off. So make those concentric. And then I can see these aren't the same either, so I want those to be coplanar. So this one, accept it, coplanar to this one, accept it. And when I say accept, it's the green check mark or right mouse click. Now these two guys here I need to be offset. So I don't know what that distance is. Let me just throw a dimension on here real quick. I can see that's 40 millimeters tall. So I want this to be 40 millimeters also. So one of the relationships that we have is an offset relationship, which is this one. So again, in this case, I'm going to persist it, which means I'm going to take this face, accept it, I'm going to offset it from this face, and the distance I want is 40. If we look over in our relationships, that becomes a permanent relationship. That means if I pick this and I start dragging it, it's going to maintain that 40 millimeter offset, even though I've only picked one. As a matter of fact, I can disable all the design intent and it's still going to do that because it's a permanent relationship in the model. Hit reset to turn everything back on again. I also noticed that
Sir, this is lesson
this
5, sir.
entire arm was rotated.
Sir, this is lesson 5.
Lesson 5. That video I'm playing now. Playing it right now.
Yes,
You
sir.
can watch that video and accordingly you can practice. Okay.
Okay, sir.
Our next lesson is lesson 5, geometric relationships. This longer, we could do that. Okay. Shorter, if we want the angled face to go with it, I would simply add that to the select set. And that way the coplanar and the symmetry would keep everything lined up in the concentric. So you can make edits really quick and easy using the relate tool and using synchronous technology. Finally, we're at the point where we're going to model some parts. You'll need to get your printouts and then we'll model these parts together.
Okay, so that was all the explanation about this lesson. There's a lot that we have to do here in this one. So let's start again with the same model. You can see this is where I was facing a little problem because this is constructed as an ordered pair. So we need to first convert all these features into synchronous mode. So how to do that is just right click on this and choose move to synchronous. If you just choose this option, the other option is, if you right click on the ordered and transition to synchronous, then the parts that you have designed using ordered pair will get frozen and you can start creating fresh parts with synchronous modeling. So whereas if you want to move the parts which are already created to the synchronous, you have to click the last, right click on the last part, last feature, and then you have to select move to synchronous. So that way all the features that you had created will move to the synchronous. You can see ordered is below and synchronous is at the top. So all the features that I had created in the ordered mode are now moved to the synchronous mode. Okay.
Sir, what is synchronous and order?
Synchronous mode is a special kind of modeling technique which is specifically developed by SolidEdge people, and it's different from the ordered one. Ordered is the method followed by SolidWorks, Inventor, Fusion 360. All these softwares, they follow ordered method of modeling, whereas SolidEdge follows synchronous method of modeling, which is slightly different. And just now in the video is explained how the synchronous method is different from the ordered method. Fine. So in the ordered method, you have to go back to the sketch and change the dimensions. Then on top of that, one by one, the features will be applied. Okay. And in some cases, it will be very difficult for us to break away from the parts which we have created and make modifications. Whereas in synchronous mode of editing, so those modifications can be done very easily. Okay. So because when so let us say I want to change this dimension. So when I double click on this, 30 has appeared here, and when I change this to, let us say, 40, so what happened was symmetry was maintained on both the sides and the value of 40 changed, and these two dimensions were automatically reduced by a suitable amount. Okay. Whereas if we go with the other method, if we go with the ordered method, that is very difficult to achieve. That is slightly difficult to achieve. Of course, that is possible with ordered method as well, but it will take a little bit of carefulness. Okay. So here it is present by default. Here it is present by default. So whenever I double click on any dimensions, I will get this toolbar. This is called design intent. This is called design intent. So this design intent will not appear in the ordered modeling method. It will not appear in the ordered modeling method. And whatever options are appearing here, those options will be maintained as far as possible. So for example, I don't want symmetry. If I deselect symmetry and if I extrude it on only one side, then only this face will move. So if I change this to 40 now, look closely which one will change. Just keeping it move. So when I press enter, you can see only this side of the face has changed. This side didn't move. Fine. So that is because I had disabled the symmetry option. That is because I had disabled the symmetry option. But if I enable the symmetry option, and then if I change it to 40, you can see both the sides, both the faces are changing by same value on both the sides. Fine. So that is what happens with the synchronous modeling method. In synchronous modeling method, you will get something called design intent, and the design intent will follow some symmetries, and whatever design intents you select here. So if I change this dimension, now what will happen? Let us say if I change this to 20, what will happen now? Because symmetry is selected, the other side, this side will also change accordingly. So let's say if I'm changing it to 20, fine, got it. So because symmetry was selected, this side also got modified. Got it. So now let us say I'm changing this face. So when I change this face, what's happening? Okay. So what happened? All the three faces have moved. Suppose I want to move only the middle face. Then what I should do? I should remove coplanar. And now when I move it, only one face is going to move. So let me move it by 30. Press enter. Fine. So you can see only the middle one has moved. Only the middle one has moved. But the same modification, if I want to do in the ordered method of modeling, it is going to be very difficult. It's going to be much more difficult. Fine. You'll have to add a lot more of features, and the modeling becomes a little difficult, more difficult to do. Fine. So all those difficulties and all can be reduced if we are going for this method. So let me go with one more example. Suppose I'm selecting this face, and if I'm moving it up by, let us say, 20. So what happened? This face also got selected. If I want to move only this face, which ones should I disable? Coplanar is already deselected, and still the face is moving. So which one should I disable here?
Symmetric, sir.
Symmetry. Right. So now once the symmetry and coplanar both are disabled, then only one face is going to move. Okay. So like this, synchronous modeling method frees you. It makes you free from all that you have done in the past. Fine. Only the current state of the geometry becomes important, and you can keep modifying it as per your needs. As per your needs. Okay. Is that understood? So of course, it's going to take some time for us to understand how exactly we can utilize the synchronous modeling to our advantage, because we have got used to the SolidWorks way of modeling, which is the ordered way of modeling. Okay, it's going to take us some time to get used to this. This is more closer to how AutoCAD designs the 3D models. Fine. But of course, with AutoCAD, we have very few options of making modifications to the solids. SolidEdge provides a lot more options, and it's much more better, you can say, at handling the complexities and making the modifications. So any other so is this clear? Okay, let's go for the next model. So just close it. I don't want to save it. Okay, so no. Then I have to go back to this lesson activity and support base. I think this was the one. So let me download this. Open it. Yeah. So this is another model that was explained in the video. And once again, you can see when I start editing something, this design intent will appear, and symmetry is now deselected. So what will happen? Only one face is getting modified. Okay. So if I deselect offset as well, only the top face is going to move. Getting it? So that way you can do it. So symmetry, if I select, then the face on the other side will also start moving. But still you can see this bottom face didn't move because offset was disabled. So let us select offset as well. And now when I'm moving it, it's going to move along with that offset face. Fine. And if I want to give a draft angle to this side, then I'll have to drag this sphere to this edge. Okay, not that edge. We'll have to drag it to this edge. Fine. And then I can start giving some draft angle to this. Fine. So when I'm giving draft angle, because symmetry is on, the other side is also coming up, and because offset is on, this lower face is also getting aligned. So if I disable offset, only the top face is going to modify. When I enable offset, it's going to modify like this. When I enable coplanar, fine. So coplanar is probably not going to work. It's going to give an error. Okay. So I'll have to disable symmetry, enable coplanar, and that's when I will be able to utilize it fully. So now, fine. We can see all the four faces are modifying. All the four faces are getting modified by whatever angle I give. So let us say I'm giving 20 degrees. Fine. So not just this face, but even these two faces and also this face. And if you see the bottom face over here, the bottom face, this face remains parallel to this face. So whatever inclination the top face takes, the same inclination will be taken up by the bottom face. So these are some of the extra advantages when we are using the synchronous method of modeling. Okay. So it was also explained. So like if you want to change this holes, you just have to select the holes and you just have to click somewhere here. Fine. And you can see that all the modifications are happening while maintaining whatever design intents I have selected here. So because symmetry is not selected, so it's not becoming symmetric, but alignment of holes, aligned holes is already selected. That's the reason why the holes are getting aligned. So if I select symmetry, now you can see symmetry is maintained in all the directions along both the planes. Along both the planes, symmetry is being maintained. Okay. So that way, so whenever you want to make any changes to any diagram, you will have to keep track of what design intents you are choosing. And of course, the design intent will start acting only in synchronous modeling method. You will not be able to use it when you are using ordered method. Okay. So you must ensure that whatever you are designing is already shifted to synchronous modeling method first. And only after that, you can start using the design intents. And next thing that he was talking about is you can apply direct constraints on 3D models. Fine. So here we had seen some constraints were available for sketches. So all these constraints were applied on the sketches. But on this side, you can see it is called face relate. It is not just relate. This is called just a relate, which means they can be used only on sketches. But if you use face relate, they can be applied on different faces. They can be applied on different faces. So this is like, this works just like a feature. This works just like a feature. And once you add this face relate to some selected faces, so those faces will always move or get modified while maintaining all these face relations, while maintaining all the face relations. Okay. So this is something we'll have to learn. So lots of files are there here. Fine. So design intent block says another file. Let's see what's there in that. So I think it is the same yellow one. Yeah, this is the same yellow one. And you have multi align. Let's see what's that. Okay, yeah. So this one was also explained in the video, right? So all the three faces are at different heights. So if you want to make them as same height, first you have to select all these faces by pressing Control. Press Control and select all the faces, and then you'll have to select face align. So where is that option?
I think we should select only three faces, sir.
Only three faces, huh?
Like he selected three faces.
Okay,
After
okay,
that,
yeah,
each
I remember
face.
now. I remember now. So three faces I have selected. So then you'll have to select some option, right? What was the option you had selected? So there was some option called align faces or something, right?
Yes, sir.
So was it coplanar?
Yes, sir.
Yeah, coplanar. Fine. So when you select coplanar face relation, you will get this option called single align and multi align. Fine. So if you see single align, if you select, you just have to select one face, and all the faces that you have selected will.
Multi-align will.
Oh, sorry. This is not changing all
Single
the three
align
faces.
we do one after the another.
Yeah, that will do one after the other. But what has happened here is that two faces have come and got aligned with this. The third face has not aligned. Because at this position, so both these faces are aligned. Huh? Let me try to move this. Okay, now all three faces are at different heights. All three faces are at different heights. Now let us try to select. So press Ctrl and select all the three options. Then let us go for coplanar. And now you need to select single align. Now select the face you want to align it to. Fine. So only the face which you had selected last has got aligned with it. The other two faces have moved by the same amount. They have moved by the same amount. Okay, by the same value, you could say. Let us try some other options. Okay, so let's move this up a little just to avoid confusion. So at this position, all three are at different levels. So let me select these two faces and go for coplanar. I have single selected. Let's select this. So this one has got aligned. Let's go back, try once again. So let me select this face first and then this face. Now single align, move to this face. Okay, so whichever face you are selecting first, that face is getting aligned, and all other faces that you select after this face, they are moving by the same distance. They are moving by the same distance. So if you want all the faces to come to a single level, then probably you'll have to select all of them first, and let's select coplanar. This time let's go with multi-align and select one face. Okay, so when I select multi-align, all the faces are raising to the same height, all the same height. Okay, so that's how it's functioning. So what I'll do is I'll just select this face, coplanar. I want to do single plane with this, click OK, and then I want to move this plane, coplanar, single face of course, with this. Fine, so click OK. So now that both the faces are now aligned, so when I edit one of them by keeping coplanar design intent, both the faces which are in the same line will get modified. Getting it? Same way, if I'm moving just this one, this will get moved. So in fact, he was telling that even if the coplanar is disabled, will both the faces move now? What do you think? So coplanar is disabled in the design intent and still both are moving together. Why is that happening? Can anyone tell me why is that happening?
Relationship.
So because it has been added as a permanent relationship. Okay. Getting it? So while adding the face relationships, if you choose the lock button, then a permanent relation will be added between them. So let us select this face and okay, let me select this face, coplanar. Here, this is the lock button. Can you see that? If the lock button is pressed, then permanent relations will get created between the selected faces, and the permanent relations will be appearing over here. But if I'm keeping this unlocked, if I'm not pressing this button, then only temporarily they will be moved to this place. A permanent relations, you can see it is not applied. Permanent relation is not applied. And when a permanent relation is not applied and coplanar is deselected, then that relation will not be maintained. That relation will not be maintained. But the same thing if I'm doing while maintaining this lock, if the lock button is pressed and then I'm selecting this face, and if I'm clicking OK, now you can see this coplanar relationship has been added as a relationship, and that has now become a permanent relationship. Permanent relationship. So now if I'm moving, Of course, both will move as coplanar faces. Both will move as coplanar faces, even if the coplanar design intent is disabled. Fine. You can even, I think, give a rotation also. So if I'm giving a rotation, applying a draft over here. Okay. So even the draft, you can see it's getting applied. So if I give -10, okay, so where is that? Oh, right. So if I'm moving it, if I'm rotating it about this plane, they will both move together. If I give -10, fine. So these two faces will always remain coplanar. Fine. Doesn't matter what is selected in the design intent. Even if symmetry is selected or not selected, it doesn't matter. Fine. They will always be moving up along with that thing. Okay. So these two faces are also, they also have a permanent coplanar relationship. So let me try to rotate this about this. Okay. So if I try to rotate this, fine. So you can see this is getting modified like this, even though symmetry is selected here. Even though symmetry is selected, it's not applying the symmetry on both the sides. Fine. So it's just applying the coplanar relationships because it's a permanent relationship. But if I delete that permanent relationship, this is a permanent relationship. If I go there and delete it, and now symmetry is selected. Now let me try to rotate it about this. So now what's happening? Now symmetry is being maintained. Can you see that? Now symmetry is being maintained. Getting it? Okay. So I understand a lot of you will be confused. Even I was confused when I started using it, but I'm a little more comfortable with it now that I have used it a few times. And I think the same will happen with you. Fine. In the beginning, you will feel a bit confused, but as you use it more and more, if you use the practice material provided, and if you follow the video, try to do everything that is explained in the video, and also try to experiment something from your own side, I think a lot of your doubts will be cleared, and you will become more perfect with using it. Okay. So that was the class for today. So we have done the class for more than an hour now. So I hope this is sufficient for today's class. If you have any doubts, I'll clear it. If you don't, then we'll move ahead to the next. We'll close the session for today. And because the mid exams are starting for second year students from tomorrow onwards, we may have to postpone these sessions until after the mid exams. Okay. And after the mid exams, because preparation holidays will be given to you all, so we'll be able to conduct 2-hour sessions instead of just 1 hour. So both the explanation part as well as practice session and doubt clearance for every lesson will all happen in a single session. Okay. So up till lesson 5 we have completed. So after the mid exams, so till the mid exams, those who have missed out any part, or those who have even those who are doing it regularly, please try to complete till lesson number 5. Okay. So till lesson number 5, everyone should have completed the practice and doubt clearance and everything. Of course, if you have some doubts left, I'll try to clear it whenever you come up online over next. And so I think that should be able to help you out. Fine. Is there anything else? This face, let me apply concentric relation over to this face. So I have clicked the lock button, so a permanent relation will be added here, and the next time I try to move it, okay, so you can see all those relations are being maintained. Okay, so there is the tangency of this surface with the arc that is maintained, and the horizontal surface, this is continuing to remain horizontal, and the fillet continues to be of same radius as we move this to wherever we want. Okay. So that's the power of synchronous modeling, and hope you will become more comfortable with this as you use more of this in the coming time. Fine. So shall we stop here?
Okay, sir.
Okay then.
Yes, sir.
Okay, fine. So practice well and try to complete up till lesson number 5. If you have any doubts, take notes of that and keep it ready. So whenever the next sessions start after the mid exams, I will clear those doubts and then we'll move on to the next lesson. Okay. Goodbye then.
Thank you, sir.
Okay.